AI is everywhere these days, and unless you've been sleeping under a rock, you probably used ChatGPT at least once before. But you read the title and are probably wondering what I am even talking about. ChatGPT is a neural network. How can it run a neural network? Well, it can do math. Barely. And a neural network is really not much more than matrices multiplied together, and some fancy activation functions and so on. It may sound complicated, I know. But if you can do multiplication and addition, you can basically do all the required calculations by hand. Which means, in theory at least, a large language model should be able to do the same. And in this video, I will attempt to find out if ChatGPT is indeed able to tell me what number this is. And no, I will not paste the image into the chat. That is cheating. For now, let's run some tests. Here, I created a small calculator app, and the catch is, it's not running the math itself. Every time I hit the equals button, it sends a request to the ChatGPT API with the formula, asking for the result. You could say that this is the worst calculator in the entire world. It is incredibly slow, costs money for each evaluation, and has a real environmental impact, because it's literally running billions of operations just to calculate 2 plus 2. Here we can see some examples. While earlier versions of the AI, like GPT 3.5, were really bad at math, modern models are just a little bad at math. Well, at least when it comes to basic calculations. It will almost never get simple arithmetic wrong, because all of the AI providers added a ton of extra training data for that. It will get more complicated stuff wrong though, like large square roots, trigonometric functions and so on. And of course, the last few decimal places are always tricky. But I was surprised about the generally acceptable performance in floating point multiplications, which is what we are interested in today. Well, that was a calculator, but I was talking about running a neural network. As I said, if we can do basic math, we can also run the forward pass of a neural net, but it may not be clear to you yet how we will get there. First, let's start with training a simple model to predict numbers. This is the image I showed you in the beginning of the video. It's part of MNIST, a very well-known dataset in the machine learning space. You can kind of think of it as the hello world of image recognition. It contains 60,000 images of hand-drawn digits, split into two parts, training and test. The training part will be used to, well, train the network, and the test part is completely new to the model, so we can evaluate its performance on data it hasn't seen before. About the model. I built a simple convolutional neural network in PyTorch and trained it for a few epochs on the training data. The model receives 28 by 28 images and outputs 10 numbers. Each output represents one digit, and whatever value is highest is the one the network predicts. So when I put in this digit here, I get these outputs. And since the number 6 has by far the highest value, we can assume that this is the digit we gave it, if our network is well trained. As you can see, the model I trained achieves a 97% accuracy on the digits of the test set, which means about 3 in 100 guesses are wrong. But what exactly do we have now? This model is really just a large list of numbers. After running the training, we have changed the numbers in the layers of the model such that it does what we want it to do. If we want to get the predictions for a single image, we have to give it to the model, let PyTorch run the calculations, and then interpret the output. PyTorch is a highly optimized deep learning framework that handles all the math under the hood, so we don't really need to worry about that. Is what I would like to tell you. But we want to run the math ourselves in our quote-unquote inference engine, so we need to get our hands dirty from this point on. For the sake of viewer retention though, I will spare you the implementation details. I retrieved all the required formulas from the PyTorch documentation, and after a bit of trial and error, I ended up with a small framework to extract the math. I can hand in my model architecture and pre-trained weights, and receive the full output formulas for the prediction. Let me explain. If you recall, our model has 10 outputs, one for each digit. That means we want to end up with 10 formulas that each take all input values and return one number. And as you can see, this is precisely what my code produced. The formulas are obviously massive, as they encode every single mathematical operation that takes place inside the neural network. On screen right now, you can see the formula for only one single output. Let's take a step back and take another look at what the meaning of this formula is. In school you learned about functions like f of x, that return some number if you plug in a value for x. This is basically the same here, but instead of just one x, we have 784 variables that are labeled x0 to x783. one for each of the 28 by 28 pixels of the input image. When I take the input values and plug them into the formula one by one, I literally get the exact same output as if I had calculated the prediction of the neural network with PyTorch. Do that for all 10 formulas and I can run the forward pass fully independently of PyTorch and with my own rules. Crafting this formula extraction tool was easily the most fun part for this project. And if you would like to learn about the library I used, check out the link to a really great SymPy tutorial in the description, after the video of course. We have 10 formulas now, but how do we give them to ChatGPT? Just pasting them in would end in disaster, both because of context length and mathematical accuracy. But what we can do is split them up into smaller parts that we can give to ChatGPT. As we saw in the calculator example, it does reasonably well with smaller calculations. So I wrote an algorithm to take these massive formulas and split them up into atomic parts. We now have 38 million of these small additions, multiplications and the occasional max of A and B from the pooling and ReLU layers of our model. And at this point I realized that is just way too much to work with. We'd have to send all of these as requests to the LLM, which would just take ages and cost a lot of money. I experimented a bit and shrunk the model down as much as I could while still retaining some sort of accuracy. After retraining, we went from 97% test accuracy to 92%. But instead of 38 million mathematical operations, we only have to deal with around 70,000 per digit now. Still a lot, but much more manageable. And these I can literally just send to ChatGPT one by one. Of course, I'm not going to paste 70,000 calculations into the website. I will use the API and make all requests via code. Even with maximum parallelization, this is going to take a while. So now is a good time to thank you guys for all the support in 2025. We finished playing Pokemon Red in a thumbnail, almost doubled our subscriber count and generally had a lot of fun projects going on. And if you're a new viewer and like my content so far, why not join in? Maybe then we can finally catch up to Baby Lala, nursery rhymes and kids songs. Anyway, a few rate limit errors later the results are in. And amazingly, ChatGPT was indeed able to run all calculations and match the results of PyTorch. Which means, yes, you can run a neural network in ChatGPT. Granted, many of the resulting values are quite a bit off, but at least they are in the right ballpark most of the time. To make sure this wasn't a fluke, I ran 9 more digits through the program. I know we can't run any meaningful quantitative analysis on this result, but we can see that 8 out of 10 results match the PyTorch output. To save money and time, I even used the dumbest model they had available, GPT 4.1 Nano, but I still had to pay around $5 to OpenAI for 750,000 requests. Had I used a smarter model, the result would have almost certainly been much better, but this is maybe a task for future me. So, here we have potentially the worst way to run a neural network, inside of another neural network. We literally executed billions or even trillions of floating point operations just to find out what a few handwritten digits are. And with that being said, I wish you guys a happy new year and I hope to see you again in 2026.